Have you ever looked up at the moon and noticed all those round pits scattered across its surface, almost like scars from ancient battles? Those are craters, created when asteroids and comets, traveling at incredible speeds, smash into the moon's surface with explosive force. Earth has actually been hit by space rocks even more often than the moon, but our craters are much harder to spot because of weather, erosion, and the constant reshaping of our planet's surface. That's why scientists act like detectives, searching for giant circular depressions, sometimes only visible from high above using satellite images or aerial photography. But finding a big hole isn't enough. Scientists look for special clues, like shocked quartz, a mineral that's been scarred and deformed by the intense pressure and heat of a massive impact. Discovering shocked quartz is like finding a fingerprint at a crime scene. It's clear, unmistakable evidence that a cosmic collision took place right there. Another important clue is iridium, a rare element on Earth's surface but much more common in meteorites from space. When scientists find a layer of iridium-rich dust in the soil, it's a strong sign that a meteorite impact happened at that location, sometimes millions of years ago. By piecing together these clues, using geology, chemistry, and advanced satellite images, scientists can reconstruct the story of ancient impacts. They even use gravity mapping and geophysical surveys to detect subtle changes in the Earth's gravity, which can reveal buried craters hidden beneath layers of rock or soil. Each new crater that's discovered adds another chapter to the story of Earth's violent and ever-changing history. It's a powerful reminder that Earth is part of a much larger cosmic neighborhood, where collisions and impacts are simply part of life in the solar system. Every crater, no matter how big or small, tells us something new about our planet's past and the forces that have shaped it. The search for craters is ongoing, and with every new discovery, we get a little closer to understanding our planet's place in the universe and the events that have shaped its destiny. These cosmic scars aren't just relics of the past, they're living chapters in Earth's incredible story, waiting to be read and understood. And so, the hunt for new craters continues, revealing secrets that have been hidden for millions or even billions of years beneath our feet. Our planet's surface is a living record, a dynamic map of ancient impacts and ongoing change, shaped by forces both from within and beyond. The next big discovery could be just beneath our feet, or hidden deep under the sea, waiting for curious minds to uncover it and add a new piece to Earth's cosmic puzzle. If Earth's been hit so often, why don't we see craters everywhere? It's a question that puzzles many people, especially when we look at the moon or Mars, where craters are everywhere you look. Our planet is a master at hiding the evidence. Unlike those barren worlds, Earth is alive and constantly changing, making it much harder to spot the scars of ancient impacts. Erosion from wind, rain, and ice slowly erases craters, while tectonic plates can bury or destroy them. Over millions of years, even the largest craters can vanish from sight, erased by the forces of nature. But the biggest hiding place is the ocean. Over 70% of Earth's surface is covered by water, making it the ultimate shield for impact craters. Most impacts land in the sea, where craters are hidden beneath kilometers of water and thick layers of sediment. These underwater craters are almost impossible to see without special equipment. Finding these undersea craters is a huge challenge. The ocean is vast, deep, and often hostile to exploration, making every search a daunting task. Scientists use sonar to map the sea floor, sending sound waves down and measuring their return. This technology helps reveal hidden shapes and features beneath the waves. Even with this technology, mapping is slow, expensive, and covers only small areas. The sheer size of the ocean means that much of it remains unexplored, with many secrets still waiting to be found. The ocean floor is constantly changing, with sediment burying craters under hundreds of meters of muck. Over time, these layers make it even harder to detect what lies beneath. Discovering a new undersea crater is rare and exciting. Each discovery can reveal new information about Earth's history and the forces that have shaped our planet. It's like searching for a needle in a haystack, one that's been buried for millions of years, hidden beneath layers of water and time. Each find is a major scientific event. These discoveries make headlines and inspire new questions about our planet's past. The ocean still holds many secrets, waiting to be uncovered. Who knows what other mysteries lie hidden in the deep blue, just waiting for us to find them. Now, let's talk about a thrilling new find, the Nadir crater, hidden beneath the Atlantic off West Africa. It lies under 300 meters of water and 400 meters of sediment, completely out of sight. The discovery was accidental. Geoscientist Uzdin Nicholson spotted it while analyzing seismic data for another project. Seismic reflection, a technique used to search for oil, revealed a bowl-shaped depression over 8 kilometers wide, with a raised rim and central peak, classic signs of an impact crater. The layers above were undisturbed, but those at the crater level were chaotic and fractured. It was a eureka moment, an impact crater hiding in plain sight within the data. This accidental discovery opened a new investigation. Was it really a crater? When did it happen? The mystery of the Nadir crater had just begun, thanks to a sharp-eyed scientist and a bit of luck. Sometimes, the biggest discoveries are hiding where we least expect them. Just because something looks like a crater doesn't mean it is one. Science demands proof. The Nadir structure's shape, with a raised rim and central peak, matches what we expect from a large impact. Computer simulations showed that an asteroid about 400 meters wide, hitting the ocean at high speed, would create a crater just like Nadir. The impact would have vaporized water and rock, triggered a massive tsunami, and caused powerful earthquakes. Seismic data shows jumbled rock layers, evidence of a violent event, but the final proof is still missing: physical samples. Scientists need to drill into the crater and look for shocked quartz and chemical traces of the asteroid. Only then can they confirm Nadir as a true impact crater. Until then, it remains one of the most exciting candidates ever found. The next step is to get hands-on evidence from deep beneath the ocean. The search for proof continues. Science is all about testing, drilling, and discovering. Nadir's story is just beginning. If confirmed, Nadir will join an exclusive club, Earth's known impact craters. Only about 200 have been confirmed, a tiny number compared to the Moon or Mars. Each one tells a unique story. The Barringer crater in Arizona is young and well-preserved, a dramatic reminder of recent impacts. The Redefort crater in South Africa is the largest, its original form long eroded but its scale still awe-inspiring. Manicouagan crater in Canada is a giant water-filled ring, possibly part of an ancient impact chain. Underwater, the Chesapeake Bay crater was discovered through drilling and seismic surveys, buried beneath sediment. These craters help us understand Earth's violent past. They provide context for new discoveries like Nadir. Each crater is a window into the forces that have shaped our world. The hunt for more continues. The most famous impact is Chicxulub, buried under Mexico's Yucatan Peninsula, the asteroid that ended the age of dinosaurs. Chicxulub's impact changed the planet, wiping out 75% of species. Here's where Nadir gets interesting. It appears to be about the same age. 66 million years old. Could these impacts be related? One theory: a giant asteroid broke apart, sending multiple fragments to Earth. Chicxulub was the largest. Nadir could be a smaller sibling, hitting days or weeks later. If true, the end of the Cretaceous was even more catastrophic than we thought. Confirming Nadir's age is crucial. If it matches Chicxulub, it could rewrite the story of the dinosaurs' extinction. Science thrives on these mysteries. The answers lie deep beneath the sea. Why does a new ocean crater matter? It's more than just a hole in the seafloor. It's a direct link to events that shaped our planet millions of years ago. It fills crucial gaps in Earth's impact record, especially in the vast unexplored ocean where so much history remains hidden beneath the waves. The discovery of Nadir proves we can now find these hidden craters using advanced technology, hinting that there may be many more waiting to be uncovered in seismic data archives. Each new crater we find helps us piece together how often Earth is struck by asteroids, and what those impacts mean for life on our planet. This isn't just academic curiosity, it's vital for predicting and preparing for future threats from space. Studying Nadir teaches us about mid-sized impacts, the tsunamis they trigger, the environmental effects they unleash, and the risks they pose to coastal communities. It's a real-world case study for planetary defense, helping us develop strategies to protect our world. Nadir also lets us study how craters form in the ocean, which is very different from impacts on land, revealing new scientific insights. Drilling into Nadir will help refine our models of oceanic impacts and megatsunamis, improving our understanding of these rare but powerful events. If it's linked to Chicxulub, it could dramatically change our understanding of mass extinctions and the events that wiped out the dinosaurs. The story of the dinosaurs' last days might be far more complex and interconnected than we ever imagined. Each discovery adds drama, detail, and new questions to Earth's unfolding history. The ocean floor is a vast, untapped archive, holding secrets that could rewrite what we know about our planet's past. Nadir is just the beginning, a first step into a deeper understanding of our world's hidden history. The Nadir crater's discovery is just the start. The real answers lie in the rock. Scientists have proposed a drilling expedition to extract core samples from the crater. This mission will require a specialized ship, weeks at sea, and drilling through hundreds of meters of water and sediment. The cores will reveal a timeline from the present back to the impact. In the lab, geologists will search for shocked quartz and rare elements like iridium. These are the smoking guns of an impact. Paleontologists will study fossils in the layers above and below the crater to pinpoint its age. If the date matches 66 million years, it could link Nadir to the dinosaurs' extinction. The answers are locked in the rock, waiting to be uncovered. The next chapter of this story is about to be written. The Nadir crater shows how science works: observation, hypothesis, and the quest for evidence. It reminds us that Earth's history is shaped by cosmic collisions. These impacts are both destructive and creative, altering evolution and the environment. The deep ocean holds many secrets, and new technology is helping us unlock them. Discoveries like Nadir prove there's still much to learn about our own planet. The extinction of the dinosaurs paved the way for mammals, and eventually, us. Studying these events helps us understand our origins and prepare for future threats. The same cosmic forces that shaped our past are still at work today. By studying craters, we read Earth's story and prepare for what's next. Science is a journey, and Nadir is the latest landmark. It connects the deep ocean, deep space, and deep time. And that's something worth getting excited about.